Hello, friends! Welcome to Coding Garden with CJ. Welcome to Code Katas, episode 26. It's gonna be a fun time. Let's say hello to all the people in the chat. Hello, Data. Welcome to the stream. Hello, Danielle. Hello, Rabbitworks JavaScript. Hello, the Coding Cat. Hello, Data, who asks thoughts on BTC mooning. I think you mean Bitcoin mining? Maybe I'll tell you my thoughts on that. Hello, Amadal. Welcome to the stream. Hello, Tycho, who says, it's been a good long while since I've caught a live stream. The last time I streamed was, I guess it was probably a week ago. A little over a week ago. But before that, I hadn't streamed for like a month. But yeah, I'm back. I'm here. Hello, Ran. Welcome to the stream. Hello, Mahidra. Hello, Beck. Hello, Joey. Welcome to the stream. Hello, Nessie. Hello, Jonas. Welcome, welcome. So if you are new to the show, all of the code that I have written in past episodes can be found on GitHub, github.com/codinggarden/code-katas. You can see every episode. You can see links to the episodes, links to the katas, links to my solutions, etc. And all of the katas that I solved tonight will be pushed up to this repo as well. I have not selected any katas, so those of you that are watching live, if you have suggestions for a kata that you would like me to solve, feel free to throw them in the chat. Otherwise, I'm just going to maybe find some. Maybe we'll take a poll if I find a couple that I like, and I'll decide which one to do. But yeah, here we are. Hello, BMax. Welcome to the stream. Hello, Alka. Welcome, welcome. Oh, that's a good call. Rabbitworks says, will you be in the CA server soon? I think you mean like the Coding Garden community app. Yeah, I've been busy and neglecting that, but yes, this week I will have time to get back and do code reviews and talk with people and stuff like that. Okay. I see. That's what Data said earlier. Thoughts about BTC mooning, meaning that Bitcoin has gone up to the moon. Oh yeah, Beck is asking, can you solve the one I uploaded to your GitHub as a problem? Is that possibly the issue here? Yeah, here is Beck. Yeah, I can. I haven't looked at this one in depth yet, but it is a 5Q. So when I get to the 5Qs, I'll probably do this one. Yeah, so definitely. Thanks for suggesting that. Cool. Okay, I usually like to start on the easier ones. Let's pick out a 7Q to solve. Right now, I have it filtered by my languages 7Q. Let's maybe choose a topic like logic. I don't know. And everyone that has a check by it, I have solved before. This will be interesting. Is this a triangle? Oh, apparently I've attempted it? I don't know. Breaking chocolate problem. Your task is to split the chocolate bar of given dimensions n by m into, small squares. Each square is of size 1 by 1 and unbreakable. Implement a function that will return a minimum number of breaks needed. Whoa, okay, this is supposed to be easy. Probably if I thought about how to solve it, it might be easy, but that seems tricky. For example, if you're given a chocolate bar of size 2 by 1, you can split it into single squares in just 1 break, but for size 3, you must do 2 breaks. Is it 1 less than the number of squares? Don't know. That's an interesting one. Maybe I'll do that one. Let's find another one. Triangular treasure. Triangular numbers are so called because of the equilateral triangular shape that they occupy when laid out as dots. For example, first, second. So this has 1 dot, this has 3 dots, this has 6 dots. Okay. This was created by Julian Nichols. Julian watches the stream sometimes. That's pretty cool. Maybe I'll do this one. Yeah, that's him. Cool. I'd have to look at this for a second to figure out what it wants me to do, but it looks potentially doable. Let's see. Don't give me 5. In this kata, you get the start number and the end number of a region and should return the count of all numbers except numbers with a 5 in it. The start and the end number are both inclusive. Okay, 1 through 9. Wait. You should return the count of all numbers except numbers with a 5 in it. Okay, so 1 through 9, the count of all numbers, except for anything with a 5, is 8, because there is no 5. 4 to 17 doesn't have a 5 or a 15, so there's 12 numbers. Okay, that's doable. Let's pick like one more, and I think we'll do a poll. So maybe choose a different topic. Let's go puzzles. Summing a number's digits. I feel like I've done one like this before. Write a function named SumDigits, which takes a number as an input and returns the sum of the absolute value of each of the number's decimal digits, for example. I haven't solved this one before, but I've definitely solved one like it on this stream before. 2 fighters, 1 winner. Create a function that returns the name of the winner in a fight between 2 fighters. Each fighter takes turns attacking the other, and whoever kills the other first is victorious. Death is defined as having health less than or equal to 0. Each fighter will be a fighter object or instance. See the fighter class below in your chosen language. This sounds fun. I kind of want to do this one. Both health and damage per attack will be integers larger than 0. You can mutate the fighter objects. For example, you have a fighter that takes the name, health, and damage per attack. Yeah, so it's like you have to create the object for it. That's pretty cool. Okay. I'm gonna catch up on the chat. Amadow is linking to a 5Q. I might take a look at this one when we get down to 5Q, but I'll keep it open. Over there. Cool. Oh, Joey's saying it's a literal Candy Crush problem. Chocolate Crush. People are saying they like the chocolate splitting one. Okay, I want to do a quick poll, though. There are at least 30 people watching. Maybe 5 people will do the poll. What can I use for a poll? Let me figure this out. That's me. Hello. I think this Slido is still active. Yeah. Yes. Okay, we're gonna do a poll. Yeah, there is straw poll. Oh, that's not it. This one. And it hasn't. Oh, it did pop up on the string. There's a super chat from Rabbitworks. Thanks so much. $2 super chat from Rabbitworks, who says, CJ, I must ask, what are your thoughts on Vue 3.0? Maybe I should do a whole episode on my thoughts on Vue 3.0. That's, why isn't this copying? Copy. Paste. Copy. Oh. This. It's Technical difficulties. Please give me one moment. Slide. Okay, thoughts on Vue 3.0. I think it's really cool that they're rewriting it in TypeScript. That's going to make it much easier for people to contribute. Um, and I say that because with TypeScript and having a typed code base, new developers that have the right development tools like VS Code can navigate the code base a lot easier. And will have a lot more suggestions in their editor if they're trying to contribute to it. So I like the idea that they're rewriting it in TypeScript so that they can get a lot more contributors and a cleaner code base. So that's cool. I like the fact that they have tons of RFCs open that pretty much anyone can comment on. Those of you might have seen the recent, I don't know what to call it, but a lot of people got really salty or like really concerned about one of the RFCs and said some pretty mean things and just got very serious about it. And that's not cool. But the result of all of it is that the RFC has been updated to say that there actually won't be any breaking changes. It was an RFC that talked about how you could write Vue components in a more functional style without having like a data property or having methods or computed. And some people started commenting saying that they hated it. It's going to break the syntax. Vue is turning into Angular 2, all this drama. But ultimately, it's not going to be a breaking change. It's going to be an option. And so the thing I like about Vue 3 is that it's all up for discussion. Like if you don't like something that's going to change, you can talk about it and you can give a reason for it not to change. What else? Yeah, I don't know. I mean, I think in general, like Vue, like it's still going to be one of the easiest front end frameworks to learn and pick up and build apps with. So I'll still be writing Vue even when it goes to 3.0. I don't think it's going to be the same thing that like what happened when Angular 1 decided to go to, well, not decided. They went to Angular 2, but it was a total rewrite. Now it's like Angular versus Angular JS. I don't know, but those were two totally completely different things. Vue 3.0 is not going to be that way, so I'm all for it. Has anyone tried typing in this URL yet? What do I do? What do I do? Okay, polls. Here we go. I'm a little scatterbrained today. I'm almost there. Aren't I? This is it. This is the winner. Okay. Here we go. This took way too long to get. There's the poll. I'm about to create a poll, but we can vote on which kata I should do. Okay, here we go. Here we go. Create a poll. Multiple choice. Which 7Q kata should I do? Option number 1 is the breaking chocolate problem. Option number 2 is the triangular treasure, created by Julian Nichols, a Coding Garden spectator and community member. What else? Don't give me 5. What else? Last one, 2 fighters, 1 winner. And I will say I'm partial to this one. This one sounds like it's going to be fun. I like object-oriented things. You cannot select multiple options. Go! Oh, I think I have to start it. Go! Vote now! Thanks, Ty Grinshaw, for putting the link. I was having a really hard time getting that link in there. Yeah, you're right, Rapworks. Not enough yerba. I had very little caffeine today. Yeah, Rabbitworks is saying about Vue 3.0. I think I'll enjoy it after getting used to it. The thing is, as far as I know, the core way of building Vue.js apps is still going to work. Like, you can still write apps the same way you've been writing apps. It's really just the internals are changing. Yeah, so it should. I mean, from my understanding, it should be the same old Vue. Okay, we have 71% of the votes for the two fighters, one winner, and 21% for the breaking chocolate problem. This is the one that I was favoring. I'm gonna do it. I'm gonna do it. That's the one I'm gonna do. Thank you all for voting, whoever voted. Stop the voting now. Okay. All right. Okay, here we go. First thing, I'm gonna pull this down locally. It is using Node version 8. I wonder if I can use a class instead of a constructor function. We'll see. All right, new file. What do we call it? This is what we call it. Cool. These are our tests. Okay, here we go. So ultimately, we have to implement a couple of things. So we have to implement this declare winner function, which takes in two fighters, and whoever attacks first, and then based on their initial stats, will return the name of the winner. Here. The return should be the name of the winner. This is the name of the first attacker. So first we have to implement either a class or a constructor function for the fighters. And then we have to fight them. So let's read this again. So each fighter will be a fighter object or instance. So we can see here when they create a new fighter, they're passing in three properties. The name, the second parameter is health, and this is damage per attack. It's a pretty simple fighting concept. You have the first fighter, and then you just attack back and forth, and the damage gets decreased. So probably the first thing we need to do is create a class fighter so that we can create instance of a fighter. I'm going to use the class syntax, and maybe I'll write it as a constructor function so we can compare afterwards. But anytime in your code when you see the new keyword, they are creating a new instance of some class. So we need this fighter class, and you'll notice my editor stopped complaining. So the moment I created the fighter class, it's just like, oh, I know what that thing is. And then this class needs a constructor. And the constructor takes in three things. It takes in their name, their health, and damage per attack. So we can see that those three things will correspond to these three things. And then the instance itself needs to know what these properties are. So we're going to put it on the instance, and you do that with this keyword. So I'll say this.name equals name, this.health equals health, this.damage per attack equals damage per attack. And ultimately what that does is creates an object that has these properties, name, health, and damage per attack. So for instance, if I were to just log fighter1 here, we're going to see an object that has three properties, name, health, and damage per attack. And it has those three properties because we put them on the instance using this keyword. So let's start up Quokka. And we can see, there it is. It logged the fighter, and it's an object that has 3 properties. Name is Lou, health is 10, damage per attack is 2. And just to show what's happening here, like if I comment that out, this object is not going to have a health property. So by using the this keyword, we're putting a property onto the instance of that fighter. Cool. So we have 2 fighters. And then we need to fight them. So yeah. Create a function that returns the name of the winner in a fight between 2 fighters. Each fighter takes turn attacking the other, and whoever kills the other first is victorious. Cool. So what we first need to do is determine which of these 2 fighters is the first attacker. So the third parameter that's being passed in here is the name of the first attacker. So let's call this first attacker name. And we need a variable that's going to be like, who is the current attacker? And in this case, they're going to be the first attacker. Initially, we don't know who they are. We basically have to compare the name of fighter 1 with this, and if it matches, then they're the first fighter. So we could say if fighter 1 dot name is equal to first attacker name, excuse me, then current attacker is going to be fighter 1. Else, it's going to be the other one. Cool. So based on the name they gave us, we determine who the current attacker is. Now we just need to go back and forth. So we need to attack one against the other, and decrease their health. So let's do this. So we probably need some sort of like while loop. So we could probably say like while fighter 1 dot health is greater than 0, or wait, so we basically want to keep repeating the attack sequence until one of them is dead. So while fighter 1 health is, we'll say greater than 0, and fighter 2 health is greater than 0. So the moment one of their health goes to 0, we know that the fight is over. Okay. Now we need to attack them against each other. So we want to do this in more of like an object-oriented fashion. So I think the fighter should have an attack function that takes in damage and then decreases its health by that damage. So here I would say this dot health minus equals damage. So when you attack a fighter, its health is going to go down. And so I guess we need probably 2 variables. So we have current attacker and then like current defender. So the person receiving the attack. That way we can keep track of both and we'll like swap them. So we'll say current defender is equal to, in this case, fighter 2, but in this case, they are fighter 1. So we have these 2 variables, current attacker and current defender. So the first thing we're going to do in like while we're simulating this fight is we're going to say current defender dot attack with current attacker's damage per attack. Right? So we are passing in the damage per attack to the attack function for the current defender, reducing their health, and then they'll swap places and do it again. So we'll say current defender equals current attacker, and then we need a temp variable to say current attacker equals temp. It's the old swapping problem. So set temp equal to current defender. and then set current defender equal to the current attacker, and then current attacker becomes the current defender. So we're swapping their places. It's going to go back around, and the other one's going to attack the other one. Okay. I realize I just coded this whole thing with no pseudocode, but I'm gonna take a break. Look at the chat. Like I said, I'm really off tonight. Okay. Okay. Yeah. And hello, Alan. Welcome to the stream. Coding Cat is asking what is Quokka? Yeah, and Sean answered. So it's a plugin that actually runs the code here. So anytime I have a console log, it'll actually show the output of the code. I'm telling you, I'm so off tonight. Woof. Okay, so you log the thing and we see what it actually is. It's actually running the code in real time. And so we can see at the end of this, so let's log the current attacker and current defender before. So before the while loop, they're just as they started. So Lou has 10 health and 2 damage per attack, and Harry has 5 health and 4 damage per attack. And then they go back and forth. And after it all, so the moment one of their health is below 0, it comes out of the while loop, and then we have Harry, who's now at -1, and Lou, who still has 2 health. So Lou is actually the winner here. And basically the last thing we have to do is just see which of the fighters has some remaining health. But one thing we could do is we could add a property to the class, something like this dot is alive, and that's going to be if health is greater than 0. So that I could just default this to true, but that way if you pass in like a negative health, they're like instantly dead. So we have is alive here, and then anytime you attack, we could update that variable and say if this dot health is less than or equal to 0, this dot is alive equals false. Just like that. And actually, I guess instead of setting a property, this could actually also just be a function. So instead of having a property here, we could actually have a function that just returns health is greater than 0. So let's do that. Let's say is alive, and this just returns this dot health greater than 0, because if it's greater than 0, is alive will return true. Cool. So at this point, when the loop is all done and finished, we need to determine which one of the two is alive. So we'll say if fighter1 dot is alive, return fighter1 dot name, else return fighter2 dot name. Simple as that. I was thinking of something else we could do. I don't know, maybe not. But if we look at this, currently, we got the right result there. We get the right result there. We got the right result there, and there, and there. Okay, so our code is working. Now, does anyone have suggestions for how I can clean this thing up? Maybe how can I make it more object-oriented? And then I'll also show how you would do this using a constructor function and the prototype rather than a class. But this is like the basic code. I think this could maybe be a little bit better. Let's see. Yeah, I like, so Archangel is saying, wouldn't it make more sense for the method to be called take damage? Yeah, because it's not the one that's doing the attacking. We could, actually, how about this? So what if attack takes in the fighter that they're attacking, and then we say fighter dot take damage with this dot damage per attack. I like this because it hides a lot of the implementation details, whereas right here we have to like reach in and grab that property. So we'll have both an attack function and a take damage function. So take damage, we'll take in the damage and then just reduce the health. So this dot health minus equals the damage. Cool. But now that we've done that, we can say current attacker dot attack the current defender. And that makes more sense. So the attacker is attacking the defender, but then when we get into this attack function, it itself is calling the take damage function of the other fighter, the one that we're attacking, and reducing it by its own damage per attack. Kind of like that. And that should all still work. Yeah, it all still works. Cool. Good suggestion. Oh, good call. Jan is mentioning a very cool way to swap variables. Yeah, with ES 2015, you can use, I think it is like, it's destructuring syntax, but it basically allows you to swap. So I can say A comma B equals B comma A, like that. But these things don't exist. So if I said, basically I'm going to swap the current attacker and the current defender, and I just swap them on this side. Like that. Nice. I don't know if this, I think this just is just a play on destructuring syntax, but it does allow you to kind of like swap in place without a temp variable. Someone correct me if I'm wrong, but I do believe this isn't like a special swapping syntax. This is actually array destructuring used for swapping. Cool. Yeah, and Archangel is commenting on how we kind of made these two methods here. So they say, as a game programmer myself who has to work purely in this style, isolating instances and having them be responsible for themselves makes sense to me. I don't know if this, there's a programming principle called the open close principle, but earlier, whenever I was like reaching in to grab the damage per attack and passing it to the function, that's like leaky implementation details. But by making it a lot simpler here, if I ever need to change it, I change it in one place, and I don't have to change it in all the places that I've called the function. So I think it makes sense to do it this way. Cool. I think I can clean this up slightly, like choosing who the current attacker is. If we default the current attacker to fighter 1 and fighter 2, then we really only need one if statement. So we'll say here, if fighter 1's name does not equal the first attacker name, then we got it wrong and we're going to swap them. Otherwise, we leave them as default. That kind of cleans up the code a little bit. Cool. And I guess the other thing is, instead of having this while loop, technically we could, it would still be a while loop, but we could return inside of the while loop. So the moment one of their one of the fighters dies, we just immediately return the other fighter's name. So we could do something like if fighter 1 dot is alive is not alive, return fighter 2 dot name. Same thing. If fighter 2 is not alive, then we return fighter 1 name. And that will like immediately exit the function, so we can just have it as simple as that. Let's see. Cool. Any other thoughts, suggestions on this? Wally Oxen is saying, how does the scope of all that work? I think are we talking about the destructuring here? I think the thing is, like, typically when you see array destructuring, you see like a let right there. And if you put a let here, then that is creating new variables. But if you use existing variables, then the values are going to be placed into those variables. And the way array destructuring works is you have the array on the right-hand side, and it has many values in it. And then on the left-hand side, whatever is here matches the 0th index in the array, and that value gets put into this variable. And whatever is here matches the first index in the array, and that value in the array gets put into this value. So on the left-hand side, this is not an array. This is a way of pulling values out of the array. The right-hand side is literally just an array with 2 values inside of it. Yeah. Yeah, Wally Oxen has a good point. Why not just do current defender.isAlive? That's a great point, because if the defender is the one that just got attacked, so they're the only one we need to check to see if they're alive, like this, and then we only have to do one check. I love it, because we can say, so we know that current attacker is still alive because it's the one doing the attack. If it was dead, it wouldn't have made it back around. And current defender is the one that just took some damage, so it's really the only one that we need to check to see if it's still alive because it just took damage. So if current defender is not alive, then the attacker is the winner. Great suggestions. There's a debate on? And hello, Topher, welcome to the stream. I'm doing Code Katas. This was a very simple simulation of 2 fighters going back and forth. It's a code kata. Oh, Wally Oxen is saying, I was meaning more of the scope of the classes. You're passing them in, but it's like global scope. So the class itself is technically, I mean, if this were running in the browser, this would be the global scope, because this class is available anywhere. When we're doing the tests here, we're actually creating instances of that class. So like it would be like storing these in variables. And so the scope of this instance is literally only exists inside of this function, because when we invoke the function, we create the instance, then inside of the function, it becomes fighter1. But then at the end of the function invocation, so when this function is done executing, the fighter1 variable isn't needed anymore. So it's completely out of scope. And then like on line 37, this fighter is no longer in scope. It's gone because it was only used right during the invocation. Another way you could write this, let's say like Lou1 equals that, and Harry1 equals this. Ultimately, this function invocation does the same thing, but because I stored them in variables before I called the function, now those 2 fighters are actually still in scope after the function invocation. I think that's what you were asking. But because we don't really need them multiple times, we can kind of just do that. It's fine. All right. One thing I'll show. Well, actually, let me throw this into Code Wars and see if it actually works. Sample tests. Oh no. Am I not allowed to overwrite? So maybe I did too much work. I think this is the only okay, I did too much work. I wasn't supposed to create this class. But if I write it the function way, so here I can do this. So I showed how to write it as a class, but if I write it as a constructor function, it should overwrite the one that they wrote. And then I can add all of my functions onto it, like this. So I can say like this dot attack equals this function, and this dot take damage equals this function, and this dot is alive equals this function. So what did I do wrong? Oh, this wants semicolons. This is one way of writing it. In a second, I'll show how to do it the prototype way, if this even works. The error I was getting right now, let me run the sample test again, is identifier fighter has already been declared. The issue is the class keyword, I believe, behaves very similarly to like let and const, in that you can't overwrite something that already has this name. And because they already have a function called fighter, it won't let me declare the class like that. But if I overwrite it, I should be able to. Let's see. Yeah, so that still works. And the main issue there is I can't redeclare fighter because in the scope of this kata, fighter already exists. Okay, this is one way to write it, but the other way uses the prototype, and that is actually closer to what's happening here. So if I want to add a function to the fighter, I can say fighter.prototype dot, and then the name of the function that I want to add. And I can do fighter.prototype.takeDamage equals some function. And then fighter.prototype.isAlive equals that function. Ultimately, the code will behave in a very similar way, but there are different implications here. By putting the function on the prototype, every single instance shares the function. And I just realized something. I can't actually use this here because I have this arrow function syntax. So if I'm doing it the prototype way, I actually do need to make these full-on functions because they need to be able to be bound to the instance. And JavaScript automatically does that for us. Like so. Arrow functions cannot be bound. Regular functions can. And so inside of here, when I say this.damage per attack, it knows, or JavaScript basically sets the this of this function to be whatever instance we're calling it on. But then all instances share the same function. Hope that makes sense. But let's try it with this way. It should still work. Sample tests. Cool, it still works. All right. It's okay, Wally. Yeah, I don't know. Maybe I didn't get enough sleep last night, but I'm feeling weird. Okay, let's submit this and then move on because I've spent way too long on it. Attempt. There we go. Nice. Oh, look at all those tests too. Final submit. Let's see how other people did it. Yeah, and so we went a much more verbose way of coding it, but I think like what's his name? Yeah, Archangel is mentioning like when you're like building a game or something like that, if you were to code it just this way without having methods on the classes, you would have a lot more code and a lot more places to update code if things change. Yeah, so very similar logic. We've just made it a bit more object oriented. They took more of like a functional approach using objects. Very interesting. This person added an is dead. They also added an attack function that takes in the other and decreases their health. We took it one step further, and instead of just decreasing their health, we called take damage of the other fighter. Yeah, that's interesting. Nobody else like added more functions to the class. Okay, moving along. Let's find ourselves a 6Q. Are these filtered right now? Oh, I guess they are. Yeah, let's look for data types that are 6Q. Katas I have not trained on. Is a number prime? Find the unique number. Let's look at it. There is an array with some numbers. All numbers are equal except for one. Try to find it. Very interesting. Sort the odd. I think I came across this one last time. I don't know. You have an array of numbers. Your task is to sort ascending odd numbers, but even numbers must be on their places. Yeah, so only the odd numbers get sorted. Everything else stays in its original place. Seems kind of tricky. Look at this one. Complete the solution so that it splits the string into pairs of 2 characters. If the string contains an odd number of characters, then it should replace the missing second character of the final pair with an underscore. That seems interesting as well. Write number in expanded form. This one seems fun too. You'll be given a number and you need to return it as a string in expanded form. For example, if you're given the number 12, you need to return a string that has 10 plus 2. If you're given 42, you should return a string that has 40 plus 2. If you're given this, you should return a string that has 70,000 plus 300 plus 4. Very interesting. Anything else? What about this? Give me a diamond. That's too long. I don't want to read it all. Camel case method? Write a simple .camel case method. All words must have their first letter capitalized without spaces. So if you're given this, that's not camel case, that's Pascal case, isn't it? I think Pascal case is where the first letter is capitalized. Camel case, the first letter is lowercase. I don't know. Let's pick like one more. Simple encryption. For building the encrypted string, take every second character from the string, then the other characters that are not every second character, and concat them as a new string. Do this n times. This is a test. Becomes this one time. So take every second character from the string. So T S I don't know how that would work, but every second character. So I think they mean like 1 2 1 2 1 2 1 2. Take the second one, put them at the end. Weird. And you do this in time. So this was done once, but this is done twice. And you create an encryption function and a decryption function. So an encryption function turns it into this, and then you have to know the number of times to be able to decrypt it. Very interesting. Okay, let's vote on which 6Q I should do. New poll, multiple choice. All right, first choice. Find the unique number. Second choice, sort the odd. Third choice, split strings. Fourth choice, write the number in expanded form. And last one, alternating split. All right. Go. And I will reshare that link for anybody that lost it. So we are currently voting on which 6Q kata should I do. Oh, what? The event didn't end, did it? There we go. Okay, here it comes again. Please vote now. And hello, we all love Pakwalan. How you doing? Good morning from India. That's great. Sean says we should do a unique number. Which one was that? Oh, the first one. Find the unique number. Yep, that one's interesting. And hello, Ever Fabio from Bolivia. That's great. Welcome. %40 of the votes for find the unique number. Hello, Eric from Mexico City. That's great. Okay, the numbers are moving. I think I'm gonna stop it there. The majority of people have voted for find the unique number. Let's do it. That one. Okay. We're gonna bring it down locally. New file. We have a function that takes in an array. And we'll start up Kata. Okay, so right now our function returns undefined. So we need to actually do the magic. But we're given an array that only has 2 different numbers in it, but one of them occurs multiple times. We need to return the unique one. So in this array, 0 is in there twice, 1 is only in there once, so we return 1. In this array, 1 is in there several times, but 2 is only in there once, so we return 2. In this one, 3 is in there several times, but 10 is only in there once, so we return 10. So we're finding the unique one in the array. So how are we going to do this? I think what I'm going to do is keep track of the count of every number that we've come across. And the moment we come across something that has more than one instance of itself, we know that the other number is the unique one. So we need like a place to store the counts of the numbers. I'm thinking like an object or something like that. Then we need to iterate over the array. And then for every element in the array, we increment the count of the current number in the counts object. So this is going to be the counts object. Every number that we come across, we're going to increment its count, and then we check if there are two numbers in the array, or sorry, in the counts object, excuse me, return the one with only one count. Yeah, I think it's it. And so by what I mean for a place to store the counts of the numbers is like, for this first instance, we would create an object that has like the key of 0 and a value of 2 because there's 2 of them, and then a key of 1 and a value of 1 because there's only one of them. And then like the case of this one, we would have a key of 1 and a value of 1, 2, 3, 4, 5, and then a key of 2 and a value of 1. So we're using this to keep track of how many there are, and the moment there's 2 in here, we pick the one that only has 1, and we know that we found the unique number. That's how I'm going to go about this. Yeah, I could, there are definitely other ways to go about this. I think some people are mentioning kind of like if the previous one was different from the current one, then we've found it. We would also need to make sure that you're not just at the second one in the array. Like if the index is greater than 3 and the previous one is the same as the current one, or is not the same, then we found it. I'm going to go about it this way, and maybe we'll solve it that way. Okay, so a place to store the counts of numbers. I'm just going to say counts. It's going to be an object. Then we need to iterate over the array. For now, I'm just going to do a basic for loop. And we're iterating over this array. And we'll create a variable called number that's going to be that given element in the array. So what we want to do is increment the count of the current number in the counts object. So I can say counts at number is equal to itself, or set it equal to 0. So basically the first time I come across a number, I'm going to put it in here with the value 0. So what this would do is if counts at number doesn't exist, so right now counts is an empty object. When I come across this 0, it's going to say, oh, this doesn't exist. So we're going to set it to 0. So we're going to say counts at 0 has the value 0. And then right after that, I'm going to increment it. So I'll then say counts at number plus plus. And that will then change it to a 1. So if it's not in there, add it. That's what this line does. And then the next line just increments it. This line also says if it's already in there, then just keep it the way it is, which is what we want. Okay, so we'll keep this stays as an empty object. Now, if there are 2 numbers in the counts object, return the one with only 1 count. So at this point, if we've seen 2 different numbers and one of them has a count of 1 and the other one has a count greater than 1, we know that we found the unique number. So the way I might do this is I can say if counts, we can do object dot keys, and if its length is equal to 2, then that means at this point we have found 2 different unique numbers, and it's really the first occurrence of a unique number. So the moment we come across the second number, we're then going to drop into this if statement. And in this case, in this array, the moment we get to the 2, we're going to drop into this if statement. And now we need to check and see what they are. So we can say, and actually let's store this in a variable. Yeah, let's store it in a variable. We can call it numbers. Let's call it entries. And then here let's pull those entries out. Do I want to do this? Yeah, I probably want to have like A and B equals the entries, and I can say if entries at if counts at A is equal to 1 and counts of B is greater than 1, then we need to return counts. We need to return A, because that's the unique number. And we need to return it as a string. For now, we'll leave it as is. And then else, if counts of B is equal to 1 and counts of A is greater than 1, then return B. And basically what this does is it makes sure that one of them has only been seen once and the other one has been seen more than once. And the reason that matters is, like in the case where both unique numbers are at the beginning of the array, once we get here, we still don't know what the unique number is because we've only seen 2 things. So we need to go one more, and at this point, 1 has a counts of 1 and 0 would have a counts of 2. And so we know that we have found the unique number. So yeah, that does it. There's definitely other ways to do this. Let's see what the chat has to say. Yeah, creating a set wouldn't solve this because we need to find the number that is unique. A set would give us back a set with both numbers. We wouldn't know which one only had one occurrence. At least, I don't think so. Maybe you're thinking of another way to use a set. Yeah, and Hatem is saying, just iterate when array at I plus 1 is different from array at I, then return array at I. That's one way to solve it, but you do have to be careful for the very first 2 values in the array, because if I get here, or no, if I get here, and if I say array at I plus 1 is not equal, then I return array at I would actually get it wrong because I need to look at least 3 elements. So it could potentially work in this case. Like I would look, is this one the same? It is, move along. Is this one the same? It is, move along. This one's different, so no, I know array at I plus 2 is the unique one. That would be one way to solve it. We just need some tricky logic when the numbers are at the beginning of the array. But I do want to solve that because I think we can handle it with like some initial conditions. Hello, Kir Mosk from Russia. That's great. It's very early in the morning there. Sean is saying, compare the original array with the unique finder and return the different one. Okay, so we have some user-submitted solutions. Let's check them out. So Sean is using sets here. Let's see what this does. Okay. We're finding the difference in set A and set B. Difference here is with set A. Um, what do we call this with though? Are we calling this with compare the original array with unique finder? We only get one array. We get one array that has just some numbers in it. So we're only given an array that has two different numbers in it, but one of them is only occurs once. So what would be the two values that I pass in here? Let me know. And then Hatem has a solution. Let's take a look. Oh. There we go. Okay, so we have an array, and we say if array at I plus 1 does not equal array at I, return array at I plus 1. It works for these test cases, but what if I did this? If 10 is the first occurrence here, this function actually returns 3 as being the non-unique one. So we need a little bit of extra logic to make sure that in the case where the two possible values are at the beginning of the array, we don't just return I plus 1. After probably the third value in the array, we can then do this for the rest of the array. Like if we can be sure that the first two values in the array are the same, this function will work. And like similarly here, like if I did 1 0 0, it returns the wrong unique number. But this I get where you're going with this, but there's just some extra cases we need to take into account. Okay, Ryan is saying split the array. I mean, the array is already split. I don't know what you mean by that. Oh, like in half. So the sets become two different halves. I see. So one half of the array is a set, the other half of the array is a set. We now, whichever set, one of those two sets is going to have two entries in it. The other one's only going to have one. And whichever entry is not in the other one is the unique value. I get it now. That makes sense. Tycho saying, does the kata not concern you with more than two number values? As far as I know, that is it. So your array is only going to have two numbers in it, but only one of them occurs once. And Hatim, no worries. So I think we can definitely expand on your solution, but like I said, we just need to account for that very tricky case where it's the first value. If it's not, then it works. Like if we do that. Or if like 10 was the last value in here, or even here. Still works. So we're gonna work on that, but we can make it work for sure. Steven is saying you could sort the array and then check each element in the array with the next one until you find the one that doesn't match. Actually, I've thought, I think maybe not that, but if you sort the array, then the unique number is either going to be at the beginning or the end. Right? Yeah, it's either going to be the first one or the last one. So we've thought of like several different ways to solve this. I'm gonna try to make this work with sets because a lot of people are suggesting it. I still don't think I know what Sean is asking. So Sean is saying set A is the original one and set B is the unique with. What do you mean the original one though? Like I guess let me show you what I mean. And actually let me go back to these original tests. Okay. If I were to create a new set with this array, I only get back 0 and 1. So what do you mean? So I would still have to find the unique value? I still don't get it. Okay, so in your solution, what we're saying here is this is like an array. And the second one is a set. Sean, I need you I need you to write how do I invoke find yeah, how do I invoke your difference function? Show me an exact example of what I would pass into your difference function because I still don't get it. I want to get it, but I don't get it. Like I said, I'm pretty slow today. Okay. Yeah, so I mean, what I kind of just showed is when you pass an array, and really no matter the length, into a set, it plucks out the unique values. But we need to know which one only occurs once. If you do that, it does tell you that 10 and 3 are the only values in here, but it doesn't tell us which one only occurred once. Okay. I'm gonna try to solve it using the way that Hatem suggested, but we can add in that extra logic. So what this is doing is it's just comparing the current value with the next value in the array, and if it's not the same, we found our unique value. But that breaks if our unique value is the first value in the array. So really, we just need to add an extra check up here. So we can say if array at 0 does not equal array at 1, then we basically just compared the first two. We know they're not the same, so we know that one of those has to be the unique one. And really, we just need to look at the third value in the array. So we can say if array at 0 is equal to array at the third value in the array, then our unique value is array at 1. Else, our unique value is array at 0, because the 0th one did not equal the third one. And that fixes it. So we just handle the special case where our unique value is one of the first two. So I believe, yeah, that still technically works. So the special case is if the unique value is the first one in the array. Cool. I think that does it. Yeah, I think it does it. Yeah, people are still suggesting it. I really don't know what's happening. Okay. One suggestion that was made though was what if we were to sort the array? One thing we can do is if we sort the array, then we instantly know that the unique value is either at the beginning or the end. So let's do this. We pretty much can reuse this logic here, but what we'll do is we'll say array dot sort. Does that work by default, or do I need to pass in the comparison function? Okay, so first we compare the first two values in the array. If they're not the same, then our unique value is the first one in the array. Else we have to look at the end of the array now that we've sorted it. So, well, yeah, if it's not the first value in the array, then it's going to be the last one. There we go. So we sort it from, I think this is doing least to greatest. And after it's been sorted, if the first two values in the array are not the same, we know that the first one, or do we? The first one is the unique one, because it's from least to greatest. Yeah. And then similarly, if the first two are equal, then we know the last value in the array is the unique one because it's been sorted from least to greatest. I think that makes sense. We can try it on Code Wars and see if it works for other cases as well. Yeah, that still works. Or if we try it like in a different order like that, that still works. Okay. So that is also an interesting solution. Yeah, so someone just shared a Stack Overflow. The one thing I don't like about it is it's a nested loop hiding in plain sight because there's an let me just pull it up. So this is a Stack Overflow question that's saying get all the unique values in a JavaScript array, removing duplicates. Ours is actually a lot simpler than that because there's only one value in there that is unique. But if we look at their solution, they're using filter, and this will take in the current value, the current index, and the array itself. So if we say array.indexOfValue is equal to that index, that means it's the only one in the array. The issue with this though is index of has to search the entire array to find that index, and this is getting called inside of a filter, which is essentially like a for loop. So you have a loop inside of a loop, and so for really big arrays, this can actually take quite a long time. Where if we look at these solutions, this solution stops going through the array the moment it finds the unique one. And that's because of this early return inside of the for loop here. So like in the worst case, we have to look at the first. In the best case, we look at the first 3 values in the array and we're done. And there's no like nested looping there. This one is very similar. It's just a bit more logic, but there's no nested looping. So if it's at the beginning of the array, we immediately found it. Otherwise, we iterate until we find it. So it's not doing any extra iteration. This one has some nested looping hidden in plain sight. So the sort function typically, depending on the implementation, has to compare one value to another. So this might actually do some nested looping. So even though this solution looks very simple, under the hood, this might actually take a lot longer because it has to sort it first. Whereas with these 2 solutions, it's just iterating through the array and then stopping the moment it finds the unique one. Liam is saying, could you try the test case like that? That is not what this problem is solving. So they're asking for the test case with this. This problem does not solve that. This problem is specifically for arrays that only have two different numbers inside of them. Not in this case, there's 3 different numbers. We would have to write a totally different like if we're truly trying to find the unique one and there's more than one, my first solution would actually I'd have to modify the entries length here, but that one can easily be modified to pick out that the 4 is the one that only occurs once. But the other solutions were not meant to solve something like that. Cool. All right, I'm gonna move right along. Apologies to Sean. I still don't know what you're asking me to do. I just don't see how, like, what. So I think what you had before was like set A and set B. Maybe. If I do with just pass in the array twice. Is that what we're doing here? Empty set. What about this one? Pass in the array twice. Yeah, I don't know. I don't know what you're asking me to do. Okay. Let's move right along. I do need to submit a solution. Let's submit this one. I like this one. We do some basic checking. Otherwise, we start iterating the array. We don't have any. We're not like sorting it or anything. We're just iterating and then returning the moment we find the one that is not unique. Go. That worked. We'll do an attempt. Nice. Final submission. It's going. Yep. This person did the sorting method. They're looking at the first 3 values in the array. If those first 3 values are all the same, then we know that any other value in the array is the unique one, and that's what this is doing here. This is doing that index of thing, but this is actually 2 loops inside of a loop. It's not a triple nested loop, but it's still a nested loop, which I don't like. Cool. I do need to copy the URL. Put in the README. There is our 6Q. All right, for the 5Q, there were 2 suggestions. The one from Beck was compare number. So we need to compare 2 numbers that are not integers. So if A is less than B, return the string less. If A is equal to B, return the string equal. And if A is greater than B, return the string greater. But the numbers A and B you're given as strings. Just a second, someone's knocking on my door. I'm back. Maybe I was just hearing something. I don't know. There was no one at my door. Okay. Cool. Hello, Amy. Welcome to the stream. Okay. The interesting thing about this problem is that A and B are not numbers. They are strings. They can be positive or negative. They can have leading zeros in the characteristic part and a trailing 0 in the mantissa part. I think those are actually math terms for the front and the back of a number. Oh, yeah, okay. But let's try this. Yeah, I think I'll do this one because it was suggested by Beck. Who suggested this one? Max subarray sum? Someone in the chat suggested this one earlier. I feel like I've done the subarray sum problem before. Maybe it wasn't called the same thing. Okay, but let's try to do this one. Create a new file. I don't really know how I'm going to do this. I mean, I think... What is that noise? I do have a camera at my front door. I'm looking at it now. There's no one there. I hear a noise, though. There's someone in my house. But I'm live on the internet, and 36 people are watching. Someone will call the cops, right? Okay. Now, the initial solution here would just to be to parse the thing into a number, and then do the comparison. But where that gets tricky is if there's very, very large numbers like this, because then JavaScript actually cannot represent those very large numbers, so you wouldn't be able to compare them as numbers. So that's where it's gonna get tricky. Like, check it. If I say, well, like, if we have this string, start up Quokka. And I say, let's log that. But if you put a plus sign in front of a string, that essentially coerces it into a number. So if I put a plus sign here, look what we get. We get scientific notation. So if we're trying to compare the scientific notation, like, yeah, let's just do this. Like, for these really big numbers, we're gonna log A. We're gonna log B. So for these two numbers in scientific notation, it's just 1E with 33 zeros. However, this one ends with a 1. And with scientific notation, you lose, what's the word? Specificity? Precision. You lose precision. So this would actually just say that they're equal, when in reality, they're not. So this is the tricky part. This is the tricky part of this problem. The fact that you can't just turn that string into a number and do the comparison. You must do something else, which we will need to figure out. Amy is asking, is really somebody in your house? I don't know. If they are, they should come hang out in the basement and be on live stream. I don't think they are. I really don't know what that noise was, though. Okay, so this is the dilemma. Like let's do the naive solution first, and then try to think about how we can make it not that, or like how we can handle very, very large numbers. Okay, so let's say num a is going to be a turned into a number, and num b is going to be b turned into a number, and we can say if num a is less than num b, return less. If num a is equal to num b, return equal. And if num a is greater than num b, return greater. There we go. So it works wonderfully for very small numbers, but the moment we try to do bigger numbers, it's not going to work anymore. Like these. Yeah, it seems to work with the one that has leading zeros. But in both of these examples, it breaks because of the large numbers. So how are we gonna solve this? Twitch is telling me, dude, someone's knocking. Is it you, Twitch? Are you at my door? I really don't think there's anybody here. It could be fireworks. It's almost the 4th of July here, and there's a lot of fireworks going off. So that could have been it. I swear I'm hearing something. Okay. One thing we can do, though. So I'm trying to figure out, how do we do this comparison with very, very large numbers? We could compare each individual digit. So if we know that these are both the same length, then we just compare each digit. And the moment one of the digits is longer than the other, we found it. And if you're comparing two numbers and they have the exact same length, or they have different lengths, the longer length is the bigger number because it has more digits. I think that's fairly decent logic, at least for that. But then things get even trickier, because we need to account for negative numbers, decimals, yeah. Let's think on it. Um, Catching up on the chat. Tim is saying, remove the zeros. First, compare lengths. If different, return what's greater. If same, compare each number and return when greater from left to right. That would probably do it. But the tricky thing is when there are decimal places. Because these two technically have the same length, but one's a decimal and one's negative, so we need some custom logic there. For these, that would be easy enough because we just remove the leading zeros and we can figure out that that is larger. I guess if a number does have decimals, we can maybe store it as two different things. So we have the whole number and then we have the decimal on the right. Yeah, so we need we need a lot of custom logic here, but let's do it. Okay, so we can't just turn them into numbers like this. Like this is the, we'll call this the naive solution. But we can't just do this. We must do better. Okay. If the length of A and B are different, we need to do this specific to A because, okay, so we'll say if the length of A is longer than the length of B, return greater. If the length of A is the same as B, iterate and compare each digit. And that will determine if it's less, equal, or greater. If the length of A is shorter than the length of B, return less. Simple enough. But now we need pretty much all of that extra logic to like remove leading zeros, to handle decimals. I think we'll handle that next. Let's just get this working for the simpler cases, and then we can try to handle decimals and negative numbers and stuff like that. Okay, so we're just gonna handle the simplest cases right now, get that working, and then we can modify to work for decimals, negative numbers, all that good stuff. Okay, so say if a dot length is greater than b dot length, we're done. Return greater. If a dot length is equal to b dot length, we're gonna need to do some comparison of each number. We'll get to that, and then another easy case here is if a dot length is less than b dot length, we return less. Okay, so in the simplest case, this returns the correct thing for less. That's great. But now we definitely need to add the logic for if they're the same length, we basically need to iterate, and then the moment we find a number that isn't the same, we've returned greater than, less than, or equal to. Okay. Iterate and compare each digit. So we know the lengths are the same, so we just need to start iterating. Create a for loop. Well, I is less than a.length. We can say num is going to be a at I. So we'll say digit a is a at I, and digit b is b at I. And we compare them. So we'll say if digit a is greater than digit b, we return greater. And like in this case, we can see that it is returning greater, but that's because it compared the first two values. A is greater, so it returns greater. Awesome. Else, if digit A is less than digit B, we're going to return less. Great. But now we need the case where it's equal. And ultimately, if we get to the end of comparing each individual value and they were neither less than or greater than, then they were all equal. So if we make it outside of this for loop, we can just return equal. And that works. Cool. Now, for these really, really long numbers, it should work, except we need to remove the trailing, the beginning zeros in the number. So, like, this one should work. And it does, because this one is one less than the other, and we're comparing each individual value, so that's great. And then this one works as well, but this one won't work because we're comparing the length, and we need to remove those beginning zeros for it to be accurate. Yeah. So before we even do the comparison, we need to remove those beginning zeros. So I guess we could create an array and then remove the beginning zeros until we get to the first digit. So like if we do a.split, a equals a.split, b equals b.split. Function will still work. We're basically just turning that string into an array, but now that it's an array, we can remove some values from it. Actually, we don't have to turn it into an array. Here's what we do. We say while a at 0 is equal to a 0. And say a equals a.slice 1. So that should remove the first letter in the array, and then it's just going to keep going. And then we can do the same thing with b. I believe slice works on strings. Okay, so if it removed all the leading zeros, and actually let's just do this. Let's just log a right here. And we can see it is removing the leading zeros. That's a good sign. And now that we have removed the leading zeros from this one, we get the right answer. So that's awesome. So slice is actually a built-in function on strings that can get out a specific section of the string. It takes a start number and an end number. If you leave off the end number, it'll just give you the rest of the string. So by saying slice 1, we're saying give me the string at the first index to the end, so it gets rid of the 0th index. So these are essentially removing all of the leading zeros. So that's great. Okay, so we've handled the really big numbers. This should work, this special case here, because we remove that leading 0 and then we compare each digit. This is where we're going to run into problems. So now what do we do about decimals and negative numbers? I don't know yet. This one should work. It does, because we remove the leading zeros. Everything works just fine. This one will not work because we are not accounting for the decimal. That one won't work. All of these have decimals. So let's handle decimals first. Okay. So I think we'll remove all of the leading zeros. That's great. But now we'll see if there is a period anywhere, then that means there's a decimal place. And I actually want to store the decimal in a separate variable. So let's do this. Let's say let a decimal equals nothing and b decimal equals nothing. And then we can say let a decimal index will be a dot index of a period. So find the index where there is a period, and then we're basically going to create two strings out of it. Everything before the period will get stored in A, and everything after the period is going to get stored in a decimal. So we can say if a decimal index is greater than or equal to 0, so is not equal to -1. So index of will return -1 if it doesn't find a period. So if we find a decimal, we need to split this number up. So we need to say a is going to be a dot slice from 0 all the way up to the decimal index. And then a decimal is going to be a dot slice from the decimal index plus 1 all the way to the end. So here, if we log a and log a decimal, let's see what we get. So like in this case, we should get a is 1,000, a decimal is 00. So a is 1,000, that's good. And then a decimal is nothing. So this didn't quite work. What if I do that? I think technically that should work. Why is it coming up back as nothing? Let's see this. Oh, I need to I need to grab the, oh no, I'm not, yeah, because I'm not, okay, I need to get the decimal first, because otherwise I'm modifying a like that. Okay, cool. So grab the decimal first and then remove the decimal from a, so it's still stored in the original value. But now we split it up, so we have our a value here and then we have our decimal value. And pretty much if both have a decimal, we can just recursively call this function to compare the two decimals. So like if the number is completely equal except for the decimal, then we compare the decimals. Otherwise, we don't even have to compare the decimals because we compare the number before that. Okay. So that's great. So that works. We just need to do the same thing for B. Okay, and if we log B and log B decimal, that seems to work. So now we are separating the number from its decimal. And now really we just need to compare it. So like in the case of this, one has a decimal, one doesn't. Let's handle this case. Like right now it's returning equal, but we're still not comparing the decimals. What is this saying? Declarative value but never read. That's fine. Okay, so basically, now that we're pulling off the decimal, we need to handle it in all three cases. So, well, not really. No, we only need to handle the decimal in the case where the length of the two numbers is exactly the same. Because if we get to this point right here, where the entire number is the same, now we need to compare the decimal place. So here we'll say if A decimal or B decimal. So if either of the two have a decimal, then we need to compare it. Otherwise, we're going to just return equal. So we should return compare the two decimals, A decimal and B decimal. And it should work exactly the same way because it's going to remove the leading zeros and just compare the two numbers, and we should get the same result. So, yeah, let's see. And now it's working. So this technically, and we can see it right before it gets called. Let's log the A decimal, and we'll log the B decimal. So in the case where we're calling it with 1000.00 and just 1000, the A decimal is 00 and the B decimal is just nothing. And then when we go in to compare those, it's going to call this function again. First, it removes all the zeros from A, so now it just becomes the empty string. And then, because they have the same length and they're both empty, we just return equal. So that's great. But if we see, for example, like this case where we're comparing 0.09 and 0.08, it actually works. But we can see that when we get here, let's comment out the other one. Comment out this one. So the value 123 is exactly the same. Then we need to compare the decimals. So we just compare 0.9 or just 9 and 8. It goes through all the same logic. It removes the leading zeros, and then that ultimately is what we use for the comparison. So that's working beautifully. I think the only thing we need to handle now is negative numbers. So what do we do if there's a negative number? We'll figure that out. I'm gonna go to the chat. Pijo, hello Pijo, it's been a long time, says, you could check what the number conversion turns each number into. If it's scientific notation, use the link solution, else do the greater than less. Actually, I kind of like that. Yeah, so like, if the number is way too big, then we need to do this comparison. Otherwise, we can just do this. Yeah, I don't know. The thing that is though, if you're comparing like a smaller number with a very large number, you have to use this method anyways, or don't you? No, yeah, because then you're technically using the length property. I don't know. Yeah, Hatim has a good suggestion. We can just replace all instances of 0 at the beginning of the string with nothing. Um, let's see. Pijo is saying if number is greater than max safe integer or number is less than min safe integer, use the yeah. We could probably do that. Hello, Tiger. Welcome to the stream. Hatim has a suggestion for splitting it on um, a period and then using destructuring. We could technically do that right here, and we don't have to do the slice thing. Let's see what we would get here. So like I would say a and a decimal equals a dot split yeah, we do get undefined a lot. But technically we could default it to the empty string like that. Yeah, this is a way easier way of writing it. We do the same thing for b decimal. Yeah, and so and we need to store that in b like that. The reason I'm not putting a let or a const in front of this destructuring is I actually want to reassign a here to be a itself after it's been split. And if I put a const there, then it would try to redeclare the variable a. And that's why I have to declare the variable before I do the destructuring. So that should still technically work. Looks like it does. These are all our decimals. So that's cool. I like that. Pijo says, "Is this one of those where you submit 50 lines and someone has a one-line solution?" I don't think so. Like, well, are there newer number primitives built into JavaScript that can handle really really large numbers? Because if there are, then we could probably just use that, and that's like a 4-liner. I don't know. Let's handle negative numbers now. um, I think we could do a so. I wonder, is the negative number ever embedded after the leading zeros? It's not. It's always at the front. So we could do a simple check right here. We could say if a at 0 is equal to the negative sign, and b at 0 is not equal to the negative sign, then we need to return automatically less. Because the a is negative and the b is not negative, so we know that a is automatically less. Easy enough. Then if b is negative but a is not, so the reverse of this, but we reverse it, then we return greater than. Easy enough. So let's see. Like this one, the right-hand sign is negative, we instantly know that it's greater. Or this one, the right-hand side is negative, we instantly know that the left-hand side is greater. Or this one, the left-hand side is... Is that all we need? That can't be all we need. And then this one, the right-hand side is... That can't be all we need. So this seems to work because it's comparing when they're different signs. But what if we are comparing these two? Yeah, so if we're comparing two numbers of the same length, but they're both negative, then we need to flip our answer. So, so here we need to say, else if b, well, a at 0, wait. Yeah, so here's what I'm thinking. If they both have a negative sign, we're going to remove that negative sign because afterwards we remove like the leading zeros. And we're going to have a variable that says like flip result. Because if they're both negative, then when you compare the two numbers, the larger one is actually less because it's more negative. So that's what I'm going to do. So if they are both negative, we'll say flip result equals true. And we're going to default this to false. And then we need to remove the negative sign from both A and B. And then we'll go about our day. We'll do the exact same comparison, but at the end, instead of returning less, we return greater, and instead of returning greater, we return less. Okay. And this is going to remove the negative sign from them. But now, so if flip result, then less, else greater. I think, does this make sense? I think it's the easiest way to handle it because then we can just do our same old comparison, but we know that it's a negative comparison, so we actually flip the result, right? Like that. And it seems to work. So the one thing that I was concerned of, this one's still broken? Wait. Yeah, digit A. Okay. Oh, it comes down to the decimal. I need to pass in flip result to the comparison here. Because when I'm comparing the decimal place, it lost track that it was here we go, and we default this to false. But now when we recursively call it, if it was flipped, we passed in true, and it will stay true. And now that works. Whew. This is a whole lot of code. This is too much code, but I think we kind of broke it down. We did it like one step at a time, and it seems like we can handle most cases. Like what about that? What about a negative 0.12? Yeah, I think we've done it. I think we've done it. Oh, and earlier I mentioned that there might be like a native really large number in JavaScript, but PJ is saying big int is still in like the spec. Yeah, so if we compare these now without their minus signs, this one's greater and this one's less. But if they have, yeah, this one is greater than that one. But if they both have a negative sign, then they are both. Then the one on the right is less. Yeah, what about two negative numbers? Like two negative whole numbers? We could try that here. Like if we compare negative 1001 and negative 1000, negative 1001 is less than negative 1000 because it's more in the red. Anything else? Okay, I'm gonna try to submit this on Code Wars and see what happens. It seems like we've handled most of the edge cases. Oh, if there are leading zeros in the decimal, I think that'll mess us up. I don't know. Sample tests. It passes. Let's just do an attempt. Maybe they didn't. Oh no! Oh no! So two out of 130 failed. Let's log what the numbers are. Oh, so comparing 2.40 and 2.4 messes up because then we compare 40 and 4. So probably what I need to do is when we get to the decimal comparison right here is we need to remove the trailing zeros before we do the comparison. And then in this case, expected equal instead got greater. These two are not equal. Not even close. What? That's just wrong. This number is greater than that number. Right? Am I missing something? But I do need to handle the decimal case. So let's just say we kind of need to do the reverse. We need to do these two, but in reverse. So we'll say while a at a dot length minus 1 is a 0, then we're going to remove the trailing 0. Oops. Okay, we haven't broken anything, but this is what I want to check. So this should actually come out as equal, but it's not, because it's when it gets to the decimal, it's comparing 40 and 4. And the code I just wrote is not working. Oh, I need to use A decimal and B decimal, not A and B. And now they're equal. Cool. This, I don't think this would always work, but it doesn't seem like they're passing that into the tests here. What's failed? Wait, did I not paste it in? Yeah, there we go. Dipped. Okay, one failed, and I'm pretty sure that the tests are broken, because I'm gonna log the failing test here, and you will see that one is greater than the other. Where's the failure? Wait, what? Wait, what? Expected greater instead got less. Oh, is that this one? That's this one. Yeah, and so this... This is, I think, this is what I was worried about. So we're comparing 81 and 701, when really we should be comparing 810 and 701. Because it's the decimal place. And yeah. So in this case, do I want to remove the trailing zeros? In this case, I want to make them the same length. So I'm going to pad it with zeros if they're not the same length. Yeah? Yeah. This is a whole lot of code. This is too much code. There's definitely a better way to do this. I just want to submit it so I can see the solutions and see the better way to do it. But okay. This code right here is removing the trailing zeros. But before we compare the two decimals, we want them to be of the same length. But then that gets tricky if the decimal starts with a 0. How can we do this? I think I pad it with zeros. But I guess I technically, yeah, pad it with zeros, because if I end up trying to compare 0.000000001 with 0.1, if I pad 0.1 with zeros, 0.1 is larger than 0.0000001. But right now I'm removing the leading zero, so it would have set them equal to. Okay, I need to pad one of the numbers so that they are the same length. Yes, okay. If a decimal dot length is less than b decimal dot length, then then I need to pad it. So while a decimal dot length, I don't even need to do an if. I'll just do a while. is less than b decimal dot length a decimal plus equals 0. And then same thing with b decimal. So we're going to pad it with zeros, so that way when we compare it, the decimal values remain not the same, but are what they should be. Nice, it worked. So we pad this with a 0, and technically we're now comparing 810 with 701, and this actually is greater. Cool. But in the other scenario that I was talking about, where we have like 0.000001 and 0.1, this is less, because this gets padded with zeros to be up to that length. Are we removing the... No, we're removing trailing zeros first and then making them the same length. Okay, I think this is the winner. This is for all the marbles. Here we go. Go! We did it! Okay, let's see how other people did it. Are their solutions as verbose as mine? This isn't as verbose, but it's really hard to tell what this is even doing. Okay. I see. So they were doing what I think Pijo suggested earlier. So if the length of the number is more than 10 digits, then you gotta do the manual stuff. Otherwise, you can just compare it like normal. So turn them into arrays, check the length, or get the longest length, and then we're going to iterate the longest length. Weird. So this, okay, this gets the length of the longest one. This isn't handling negative numbers or decimals. Huh. This is my solution. Yeah, I wonder why my solution showed up there. Weird. Everyone's code is really hard to read. Like, I don't know if this is true or not, but I at least try to write code that if I start reading it from top to bottom, I have a general idea of what's going on. Whereas something like this, I really have to parse each line. So we are replacing all the zeros, and then this is a is this doing... Yeah, this is doing something with the decimal place. I don't know what that it would take me a little bit longer to figure out what that regular expression is doing. Let's look at this one. Okay, so yeah, they did the same thing we did, where you compare, if you see a negative sign, you instantly know which is which. Oh, this is clever. Instead of having that variable that we have, which is flip result, they literally just put B inside of A and A inside of B, so that you don't have to flip the result. That's pretty cool. Hey, they did a very similar thing. So they have the decimal variable here, just from splitting, and they are using destructuring, so that's cool. Um, this is creating leading zero. Is it leading zeros? Yeah, this is putting leading zeros on both AC and BC to make them the same length. And it's putting trailing zeros on the decimals to make them the same length. And then they do the comparison. Wowee! Okay, that's cool. This is probably the roughest episode of Code Katas that has happened yet. I've just been totally out of it. We did it though. It's a whole lot of code, but we did it. Yeah. Yeah, Pijo is saying people are more into being clever in these, so they look. He says stupid. I mean, I think they just look like hard to follow. I don't know. Cool. I'm gonna go now. I am so out of it. This was fun though. We solved some katas. We wrote a lot of code. Was it the best code? Maybe not. Was it code? Yes, it was. This one was fun. This one was fun. We did some object-oriented programming. Cool. All right. I'm done now. I am gonna stream again. Probably like 2 more times this week. I need to figure out my schedule, but streams incoming. I'm definitely gonna do an episode on deploying with Now version 2. I'll probably do that maybe Friday. And then this weekend, I have a special a special stream that is leading into a stream that I'm going to do next week. We'll talk more about that on either Saturday or Sunday. Watch out, look at the channel to see when the upcoming streams are. I will try to have more sleep before the next episode, so I'm less spacey. But look at my channel, you'll see any upcoming live streams as I schedule them. Yeah, thanks everyone for tuning in. Last comment from Pijo, those nested ternaries are gross to me. Yeah, I'm guilty of writing code with nested ternaries and ignoring my linter, which tells me not to nest ternaries. Mainly because I don't want to write it out, and I'm the only one that's going to look at the code, but I know exactly what you mean. Cool. Yeah, that's it. I'll push up all this code to GitHub. Thanks to Beck for making the suggestion on Find Unique. That was super fun. And we'll see you soon. So wherever you are in the world, have a wonderful morning, afternoon, evening, or night. Until next time, here's this.